if you want to shift it on upside, so you can right click, you can select this grid first like this, and then right click, and here is the flip option where you have to search flip at the bus. Then you can see the bus goes on the upper side of the grid goes on the upper side of the bus here. Or if you click like this, you can select a new project, and you can select the nominal bus voltage at 11 kV and click OK. Load flow analysis and execute. Oh, now it has run. Then we have run the project. Right click and select the edit forming for edges. You can click here like this. You can see, you can show here the preview. It was, see, if you want to increase the number of decimals by 2 and by 2 by 3, show units. If you want to show also the units, then it can be like this and click OK. Now you can see here we have got that we can adapt the size width. Now you can see. Hello friends, welcome to Electrical Design Engineering YouTube channel. This is our lecture number 2nd of our free course DigSilent PowerFactory. In this lecture we will make a simple SLD and perform their load flow analysis and run their simple SLD here. In this way you can learn how you can make simple SLD in the DigSilent PowerFactory. The first window, when you open the DigSilent PowerFactory, you will get this. The first window you will get is this window. So I can close it and go to file. You can select here the new project. I will select here the project. In the new, you can select the project, and here you can name it, that we name it test YouTube project, okay. And then you can, here is the project settings, you can select like this and go to the inputs, and in the inputs you can select here the unit. There are metric and English transmission and English industry. Generally we keep it metric. Then there is a lines, cables, length, unit meter. That means the length of cables or lines in which you want to enter. Suppose if you want to enter in the meters, then you have to keep like this, blank this. But if you want to enter the length of the cables or line in kilometers, then you have to select the K. Similarly, for load machines P, Q, and S values, if you want to enter in the megawatt, mega kVA, mega MVA, then you can select the M. But if you want to enter in volt amperes, watts, then you can select kept it black. So I will kept it kilowatts. I want to enter the kVA or kilowatt, kVAR. So then there is a currency. You can see there are different currencies. Whatever your currency is, whatever is suitable for your project, you can keep it. And then click validation status draft and close, and then click OK. Now you will get this window. In the here you can name it again. We can name it test YouTube, okay. And then there is a frequency, nominal frequency. You can select the 60 hertz or 50 hertz, whatever frequency is your of your project. You can set this here. You can enter the name of the owner of the project here. Then there's a load flow, consider interchange schedule. So this is the basic data, basic settings of your project. Then click OK. When you click OK, you will get this window, and here you can make your SLD. So we will start building the SLD. First of all, when you start any project, you can select, first of all you should need a one utility or a generator. Generally we are using the utility, we are taking the utility. Before that you should take the first bus and create the bus here, and then you can increase the length of the bus like this, okay. Then you can take the grid, this is the grid, and select here. But you are seeing that the grid is coming on the below, the bus. If you want to shift it on upside, so you can right click, you can select this grid first like this, and then right click, and here is the flip option where you have to search flip at the bus. Then you can see the bus goes on the upper side of the and the grid goes on the upper side of the bus. Then we can have take the double click on the grid, and in the grid you can name the grid here. If you want to name it, you can name it, but here you can select this is the terminal. You can select like this by clicking on this arrow, and this is the bus data. Here is the terminal. You can select on like this. You can set here the voltage, the line to line voltage. Suppose we can keep it 11 kV. Okay, and you can select like this here, or if you click like this, you can select a new project, and you can select the nominal bus voltage at 11 kV and click OK. You can also define zone area, and you can also define here the system is AC or DC, phase technology ABC or ABCN, that is 3 wire or 3 phase 3 wire or 3 phase 4 wire. You can also define, we can generally keep ABC. You can also define here bus, junction, node, internode, and you can select earth whether this is earthed or not. Now we can go to the load flow. This is the variation. Suppose if you want to plus minus 5% variation in voltage are allowed, then you can set in there this variation here, and then click OK and click OK, and then click and then go to the load flow. Here we can see you can enter the type of bus. You can select here slack bus, or you can select the PV bus, you can select the PQ bus, but generally in every system, in every project, you should have a one slack bus. So we select the slack bus. We have considered the voltage set point at 1 per unit and the angle 0, and click OK. Then I will take another bus and put it here like this, and then I will drag it like this, and then take the transformer. This is the transformer to winding transformer. I can connect with this one side to this side and another side to this, and the transformer has been inserted between the two buses. Then press escape and double click on the transformer, and in the transformer the bus data, this is a two winding transformer. If you want to name this two winding transformer as per your project, you can name it here. Then you can click this down arrow and select new project, and here you can go to bus data and you can enter the power rating of the transformer. Suppose I want to enter which is 1 MVA, so I do not want I will enter suppose 100. I will suppose let it be 1 MVA. Frequency is 50 hertz, and HV side voltage is 11 kV, and LT side is 0.433. Okay, here you can select the vector group, and HV side it is D and DYNN, and there you can shift the phase shift D1NN11, that is 30-degree phase shift. Okay, this is the short circuit level voltage, and this is a copper loss of the transformer. And you can go to here load flow. You can enter here the no load current, no load loss, then complete short circuit. You can positive sequence impedance, positive negative sequence reactance. These are the other things you need, but I will show you one of the project I have done in the DigSilent, and I will show you how where this data you can get and how you can enter this data. For this time you need this basic information, so you can click, you can select here technology, like it is single wire earth return, single wire single phase transformer, 3 phase transformer, but generally I have kept it 3 phase. Click OK, and then you can click OK again. Then you can add a load one. We can select here the general load and connect here the load, and press escape and double click on the load, and in the load you can select here the new project to general type of load. You can name the load, or you can select the type of the load, AC or DC. It's just three-phase earth and three-phase. These are different types of loads. You can go to the load flow and basic data and click OK. And here in the load flow you can select the load flow here, and here you can, by default it is active power and reactive power. But if you want to change this default, suppose you want to, you have active power and the power factor of the load, then you can select active power and power factor of the load. He will ask you about the active power in megawatt and power factor, whether it is inductive and capacitive. You can select, suppose I will select zero point 0.5 megawatt, and suppose or 0.4 megawatt, power factor is 0.8 and voltage is 1 per unit. And then you can select OK. You can click OK. And now we will go for the simple simulation. Here calculations is, you can select the calculation, then there is a load flow and select the load flow. And here you have active load flow base balanced positive sequence. You can execute. There is a problem, the last command error, see output of the window. Okay. In two winding transformer, the nominal voltage differs by -9 degree from the bus voltage. We can double click on the transformer. Here is some problem. I can select the load flow. I can see what is the problem. Okay, it is okay. It is okay. Bus voltage. Click okay. What is the problem? Oh, 1 minute. Okay. What is the bus voltage here? Okay, 11 kV is okay. What is the bus voltage here? Oh, here the bus voltage is. See, one problem is there. I have observed here the voltage should be 33 kV, but here the voltage is 11. Okay, our grid is 33 by 11 or 11 by this. We can select first. We can see here the basic data. It is load flow. It is basic data. Where we have 1 minute. Now you can see here what is the voltage. Voltage here is should be 4.33 because it is connected to the low voltage side of the transformer, which is voltage is 0.433 kilovolt, and click OK. Now we can again go to load flow analysis and click load flow and then click execute. This is again showing some problem. Now click OK, and then you can double click here, and now we can check again what is the voltage here. It is 11 by LV, HV side is 11 and LV side is 0.433. It is okay. Then we will go to the HV side, and here we can see, oh, it is 11 kV here. This was wrong. Connection is, click cancel, click OK. Now I will select the LV side. On the LV side we can see, oh, it is 0.433, and click OK, OK, and OK. Now we can go again for the load flow analysis calculations, load flow analysis, and execute. Oh, now it has run. We have run the project. You can see now the values has come. Okay. Now in this way you have learned two things: how the project, how the error is allowed. But one thing is that you get the values here in these boxes, but what is these values you do not know. When you put cursor there, then it shows P is this, Q is this, I is this. How you can display these things also? You can double click on this. You can do one thing. You can right click it and edit formatting, and you can select it. I will show again you. Select this, right click and select the edit formatting for edges. You can tick here like this. You can see, you can show here the preview equals. See, if you want to increase the number of decimals by 2 and by 2 by 3, show units. If you want to show also the units, then it can be like this and click OK. Now you can see here we have got that we can adapt the size width. Now you can see you can right click and adapt the width, right click and adapt the width. See, now you can get P is this, Q is this, I is this. Similarly, you can right click here and go to the edit format, edit this, double click here, double click all these things, double click here, kept it to, just to kept it to and click OK. Now right click and adapt it. Now you can see UL line to line voltage is this. This is 1 per unit. Phase angle is 0 degree. You can see. Similarly here, you can right click and adopt. You can show here the phase is minus 30 degree because dyn 11 is this transformers vector group. Okay. Now in this way you have learned a simple diagram, how we can display the results on the diagram, how we can adjust the width of the box, display box, how we can let the display box to show the what values are, what is P, Q, I, these things. In the next lecture we will move forward with this course. Thank you.